Okay, for the next part of 4.3, I'm breaking this up into its components here. Okay, I want to talk about horizontal and vertical shifts. So just for a moment, let's consider this function. F of x is equal to the square root of x plus or minus a. Okay, so the square root of x is a square root function. It's going to look like the shark fin graph like I have over here, right? But the question is, I'm wondering, what does this, if I add or subtract a value to any of my parent functions, what does that do to the graph, okay? So here's what I have written down, right? F of x is the square root of x plus a, all right? And right now, a is set to 0. And as you can see on the graph, this is exactly what we would expect to see, a regular old sort of shark fin looking graph, a square root function, right? So as I move a to the right, if I increase a, if I add 1, notice my graph moved up, right? If I add 2, notice my graph moves up 2 units. If I add 3, it moves up 3 units, right? So it seems like when you add a value to the end of a function, it moves it up. All right, well, what if I add a negative value? So I go back to 0 here. And if I go to negative 1, well, of course, the graph moves down, right? Negative 2 moves down. So therefore, if I'm adding anything to my function, it's going to move it up or down. Up if a is greater than 0. It'll be down if a is less than 0. Okay, so let's try and compare that to this function, right? And I'll set a back to 0 here for discrete values. So if I was going to consider f of x equals the square root of x plus or minus a, and notice the a is now underneath the radical. Okay, so the a is part of the function. Okay, what does that do to my graph? Well, if I make a positive, like put a 1 there, most people would expect that my graph would move to the right because it's a is positive. But if I do that, you can see my graph has moved 1 unit to the left. So if I move 2 units, if I add 2, and notice it moves 2 units to the left. That's because we're increasing the value of the domain. So the domain can now be negative 2 and everything greater than that. So if I go back to 0, if I move my slider to the left and add negative values of a, notice that my graph moves to the right. So it's opposite what you think, okay? So these are horizontal changes. So my graph, your function will move to the right if a is actually less than 0, and to the left if a is greater than 0. It's counterintuitive what you'd think it would be. Okay, so let's try and predict what this is going to look like here. And I'll get rid of that real quick. Okay. So I asked everybody, okay, now that you have the square root of x plus 2 minus 5, what do you think the graph will look like, right? Well, we knew that since it's a square root function, it's going to be the general shark fin shape, okay? And since the negative 5 is outside of my function, it's going to be 5 units down. So the vertical will be 5 units down, right? So that's why we wrote a negative 5 right there. And since the positive 2 is inside the function, it's going to be 2 units to the left. So we would expect this graph to be the shape of a shark fin, 5 units down, and 2 units to the left. And we will graph it right now to verify that. Oh, try that again. There we go. So let me bring this over here. Okay. And let's zoom in. And we can see that indeed, right, this graph has been moved 2 units to the left, even though it says positive 2, 2 units to the left, and 5 units down for the negative 5. Okay, let's try another one, right, as an extra example here. Let's see here. If I gave f of x was equal to x squared minus 3, right? Well, since it's an x squared function, we would expect it to be a quadratic, so it would be a parabola, but the minus 3 would be moved down 3 units. So if I were to graph this, I can see a parabola that has been moved down 3 units. Now let's compare that to this. What if I gave f of x is equal to x minus 3 quantity squared? Well, because the 3 is part of this, inside my function, it's going to be 3 units to the right. And there you can see the blue graph. Okay, let's do one more example here. Let's clear this stuff out. Okay. Let's get rid of this. And let's get rid of this one here. Okay. Let's do f of x equals, how about 1 over x plus 2? Okay, so it's 1 over x, so we would expect this to be looking like the Hurley graph, and then 2 units to the left. So let's see here. Well, that's terrible. Yikes. Okay, so what is going on here? Yeah, we can see that this has been moved 2 units to the left, right? If we compare that to f of x equals 1 over x and then plus 2, right? Oh, this doesn't look like it recognizes what I'm saying. Yeah. There we go. There we go. 1 over x plus 2. This would be the Hurley graph except moved up 2 units. And there it is there, right? The difference is because the 2 is being added to the function, or in this case, the 2 is being the 2 is part of the function underneath the radical. The underneath in the denominator here. So this one is going to move it left and right. This one's going to move it up and down. Okay, there's horizontal and vertical for you.